and welcome to my presentation on the rest of the story, securing a Raspberry Pi home monitoring system. You can contact me at Laurel Marotta at intentionalprivacy.com. He already told you a bunch of things about me, but I thought this was apropos. Tinker, Tailor, Soldier, Spy. I've been a tinkerer since, well, as an adult, since we were in college, my husband Michael and I, and our 73 Ford Pinto needed to have the carburetor rebuilt. And we were in college and didn't have an extra $200. So I said, Michael, I have no idea what a carburetor looks like. Go take it off the car and I'll rebuild it. And I did. So as for the Tailor, I volunteer at SCORE to give presentations on data security so that potential business owners can better understand how to tailor their security needs to their business. SCORE's nonprofit mission is to help people get their small businesses started. Soldier, I like working in the trenches. God save me from being in management, please. And Spy, I enjoy risk assessments. I think you have to be a little bit Bond-like to like this type of work. So there's been 12.5 million Raspberry Pis sold since the Pi launched in 2012. As you can see, the Pi 2, the 2B, and the 3B are the most popular. Pi projects are limited only by the imagination. You can do all kinds of things. So there's 12.5 million boards out there, and true, some of them are broken or lost, some are still in the original packaging, and some are not even hooked up to the internet. But the ones that are hooked up to the internet, there's very little information about securing a Raspberry Pi, although you can find bits and pieces if you look. But someone has to know to look, and they have to understand about the importance of security and the consequences of insecurity. So how many parents are just going to turn over a Raspberry Pi to their child because they think it's just a toy and they're not going to worry about that it's hooked up to their network? Or even an IoT device such as a home monitoring system. As an illustration of how people do not pay attention to physical security, much less IoT security, my neighbors are constantly posting stories on nextdoor.com about vehicle break-ins in our neighborhood. Many of them do not lock their vehicles. One woman posted that someone had broken into her boyfriend's car and stolen his laptop from the trunk. Then she wrote that the first time this happened, would the person who stole it please give it back since it was a work computer, or if someone found it, would they please call her? I have no words to describe my reaction to this story. So when I first started doing this, I looked at commercial versions of home monitoring systems also to see what was possible. Something that was missing in most project plans was any discussion of how to secure the thing. So the happy path project management is the quickest path from thinking about an idea to implementing it. Then I realized that a project like this is like any other project that I've worked on at work, at any job I've ever held. So why would I need to secure a home monitoring system? Well, these are some project security considerations. And the first thing you want to start with is looking at the project. And then you want to think about the hardware that you're using, how to secure it physically, because a Raspberry Pi monitoring system could be outside someplace. It could be, like above your garage doors, so that you could watch the front of your house. You need to think about the software that's running it. You need to think about how to protect it on the network and the user and privileges, groups, patching, monitoring, backups, all the usual things that you think of when you think about securing devices. Some projects start out by using an image that contains their software bundled with an operating system. One such project is called Motion iOS. And I personally think this is a bad idea because you have no idea what they're really doing. This method is easy to do, but you lose control over what's going on with the Pi. Some images could even, whether accidentally or on purpose, include malware. So I eliminated those projects from consideration immediately. So what could go wrong? Well, there's a lot of things that could go wrong in a project like this. But at some point, you have to have a prototype so that you can have things to test. Then you think of possible failure scenarios and how you want to respond to them. I've listed several points of failure for a home monitoring system. Let's examine one of the failures. Power outage. What can you do to mitigate a power failure? One possible solution is to hook the Pi up to a solar cell. If there's enough sunshine to power the cell, then you're golden. Next, I looked at a project called Private Eye Pi. And it got several really bad reviews, especially about security. He was using, the Private Eye Pi site was using a HTTP site, and the password was in clear text in the website. Good, very good. But the project did many of the things I wanted to accomplish: sending email, creating zones, alarm status, logging, monitoring from your phone or your computer. And I also didn't like the idea of using a cloud account in their site because of the aforementioned, clear text password. And while I feel that they have changed things because they've since switched to an HTTPS site, and I did a Qualys scan on it and it came up as an A-. But even so, it just makes me feel a little queasy. So I decided that I would start small to make sure that I could build the sensor system and then add features and more sensors as I became more comfortable working with the Pi and electronics systems instead of starting with a project that was too ambitious and possibly losing interest and focus. So this was the project that I chose. It's called Monitoring Your Home with a Raspberry Pi B+. It was very basic. Some of the documentation had a lot of missing pieces. In particular, the code was not well documented. And on page 16, he lists the only security issue in the whole paper. One last word, be careful with this. Right now, anyone can access this interface with the right URL. And I'm like, okay. So one thing you really need to think about is buying parts from a reputable dealer in the US. And these are several that were listed from the raspberrypi.org site. That way you can be certain that you're getting what you paid for rather than counterfeit junk. And there are sensors out there that are not well tested. So as I said, you really need to be careful about what you buy. So the cool thing about building a Raspberry Pi is that you can choose the hardware and the software that you want to use. The hard thing about building a Raspberry Pi is that you have to choose the hardware and the software that you want to use. So I had a Raspberry Pi B+ kicking around, so I started with that. Next, I decided on a project plan, which I already talked about. Then I chose Raspbian Lite. And the reason for this is it's based on Debian and optimized for the Raspberry Pi hardware. And since I didn't need the desktop and the extra software, that's why I chose the Lite version. Mostly for children, you can get the whole download. It has a lot of software packages that are specifically meant for kids, and it's really easy to use. The only part that I actually had to buy was a DH22 sensor, and that looks like this white thing, which you probably can't see very well. But that's a humidity and temperature monitor. So one of the first things that you need to do as soon as you get the software up and running and before you plug in the Wi-Fi dongle is to change the default password, which is Raspberry. And you can change it either through Raspi config or manually through the command password before you add it to your network. So This is the GPIO layout, and GPIO stands for General Purpose Input and Output. It's a connector that allows you to connect external hardware to the RPI. And on the Raspberry Pi, it's this long black bar here, and I have a breadboard hooked up through a Raspberry Pi T-Cobbler Plus, which makes it very easy to connect up the hardware. And a tip that I'd like to give you is it's much easier to buy labeled bags of resistors than try to figure out what whether the colors on the bands on a resistor are actually red, brown, or orange. Those tiny lines look too much alike. So this is the assembled Pi, like you see here. And Raspy config allows you to do all of these things. You can change the user password, you can change the host name, and you can set up localization options for language, which includes your keyboard layout and time zone. And then the interfacing options allow you to enable the camera, use SSH, SPI, and I2C are actually part of the GPIO. And then the remote GPIO. If you don't enable the three, the SPI, the I2C, and the remote GPIO, the hardware that you attach externally will not work. And then one of the first things that you want to do is expand the file system so that you actually have access to all of your SD card. This is the software that was either listed in the project plan or that I used because there was some part that was missing. So one thing you should do whenever possible is to check the file checksum of each piece of software if it's available, but it's especially important for the operating system, and stick to the official ports as much as possible. One bad thing about Debian, which is what Raspbian is based on, is that it's hard to tell what version of software is actually running because they backport the security updates. Another gotcha, default installs with clear text passwords. Fortunately, I discovered through an Nmap scan that the NetTalk server default install comes with a default clear text password, which needs to be changed, but I had no idea that that clear text password was the default, even though I Googled NetTalk before I installed it and read it as much as I could about it. And as I previously said, the author was talking about ngrok, which creates a tunnel between the RPI and the ngrok server, which I did not install, because that's the software that he was talking about that sets up an interface, and all it is an HTTP URL, and if somebody just finds it, they can get into your system. He says, in this case, you better put a solid login password system on your server so that only you can access it. But my thought was, I thought that it would be better to just use SSH. And installing software is an interesting challenge in Linux because often it shouldn't need to be installed with sudo. However, I could not get node.js and some of the necessary modules to install without using sudo and the unsafe perms and global options. And even with those options, I still had to go in and change the user and group on root because Node.js kept changing it to me, to my user and group, Calamia and sudo, and one of them it changed to dial out, and I have no idea why it was doing that, but it did it twice. You need to physically secure the Pi so that it can't be easily stolen. Power issues are always a problem. Because Texas, I've never seen a breaker box outside before I lived in Texas. Where I grew up, the breaker box was located in the basement or maybe the garage, never outside, and never unlocked. So another problem is internet outage. Will the Pi come back online and restart its systems, or does it require a manual restart? And do you have scripts that check things like available space and logging? Do they have, or can they email you a report daily or send you a text message? So one of the problems when you're doing software updates is that the sudo apt-get update and upgrade and dist upgrade don't check for space available on your little card, your SD card. So you could hose the whole thing because you didn't have enough space to do the upgrades. Personally, I think they ought to fix that, but what do I know? So connecting to the Pi, you have several choices. The kit that I bought came with a USB console cable, which I thought was interesting. And it's really easy to hook up. It just takes a driver and plug it into a USB port and, you know, hit return and you're in. And, well, you've got to put in the password, but you can also add a Raspberry Pi 7-inch display. I don't have that up there because I don't have one, so there was no way I could test it. But a monitor and a keyboard are also very easy to use. And you can SSH using a private and public key. That's called, or it can be called, a headless system if you do not have a monitor and keyboard attached. And you usually use SSH with a headless system. So this slide shows the settings I used to set up for WPA2 Personal in WPA Supplicant. And you'll notice that I took out the PSK and the SSID. And you can use WPA Supplicant for both WPA and WPA2. So once your Wi-Fi is attached to your network, you can use the iwconfig command to verify that the Wi-Fi settings are correct. And that's what they'd look like. So passwords should be required for all systems. And one of the first things that I did was create a new user. I called it Calmia. And then you need to make sure that the user's in the correct groups, especially sudo and GPIO, and make sure that the user can log in, and then remove the Pi user and home Pi, because it's one less vector that anybody could attack. So for authentication and authorization, you should require a password for sudo, and obviously require a password for login. And if you're paranoid, you can regenerate the SSH host keys. There is an interesting discussion. Well, the SSH host keys should automatically regenerate during the first boot, but I couldn't verify whether Raspbian does or does not regenerate the SSH keys correctly. And that's a problem because if you have weak keys, somebody could hack into your system. But there's an interesting discussion about initial key generation at the link below, the raspberrypi.org forums view topic, that one. In any case, it's really easy to regenerate the keys. It's just those two commands, and I strongly advise you to do that. So for remote access, I used SSH and just added the public keys to SSH authorized keys, and then changed the permissions so that it could be read. And the way I did that was on the Windows box, I opened up Pageant and loaded in the key, then opened up PuTTY and chose the settings I wanted, including the directory for the key that I wanted to use. And then anytime I want to open up an SSH window, I just open up PuTTY and click, and it opens right up. I don't have to type in a password after I load it into Pageant. And then I save the profile. There's an excellent tutorial at the Random Notes of a Sysadmin blog. And then I went through a similar process using Juice SSH for my phone, which is an Android. And then after verifying that everything works, change the lines on the bottom in the SSHD config file. And make sure you verify that you can no longer get in with a password. And I will make my slides available, so if anybody wants them. So this is logging into the RPi from my Android using Juice SSH. It's a little hard to see, but it works. And Juice SSH is very easy to use, even the free version. So patching is always everybody's favorite thing to do. Anybody here love patching? No? Okay, so for patching, you can either do the manual way and set a calendar appointment so that you do it a certain time and day, and then anytime you add a new program, you should start out by running the first two commands anyway, and then run sudo apt get install for that package. I mean, if it's a package that needs sudo rights. And you have to be really careful with dist upgrade because it can add things that you might not want to add, and it can also remove things that you might need. So you need to read that one, as I found out to my distress. But my pain, your gain, right? And then another option is to set up automated patching by installing a package called unattended upgrades. Or you can also set up a cron job. So here's how to check to make sure that the unattended upgrade is working like you expect. Then you can compare it to the results of the sudo apt get update. And it's also a good idea to read the log file to make sure that your automated patching is working as it should. Run the update and upgrade commands occasionally to catch any patches that are not suited to automated patching. Oh, you can't read that at all. Sorry. But what the screenshot shows is the difference between running an unattended upgrade and manually running the upgrade. Next, we're going to talk about firewalls. I installed UFW, which is short for Uncomplicated Firewall, and it really is uncomplicated. It was very easy to use, and it worked great. It's simple to set up, the syntax makes sense, and it correctly writes the IP table rules for you. By default, UFW is set to deny all incoming connections and allow all outgoing connections, because you trust your users, right? Yeah. You can allow or deny a service by name or by port, and you can specify a protocol. So as you see, the one rule is sudo UFW allow SSH/TCP, so it will only allow SSH to go out over TCP. When you want to delete a rule, you can list them by number, and then it's easy to determine which rule to delete so that you don't make a mistake. When your rules are set the way you want them, disable UFW and then enable it and then reboot. Make sure you have a way to get back in case your rules are too restrictive. You need to have SSH or a keyboard monitor available, because I read several horror stories. It didn't happen to me, but I did read several horror stories. This slide shows a simple UFW rule set activation. So it allows SSH from anywhere, and it allows all traffic on my internal network. Fail to ban is a monitoring program, and so you install it. You create a jail.local file for your rules at etc fail-to-ban jail.local. Then you restart the service, and it works pretty well. And again, that's very difficult to see. But what this screenshot shows is my jail.local file. It has fail-to-ban watching /var/log/off.log. Most log files in Raspberry Pi are in the /var/log directory. And it also tells the number of retries allowed before the ban takes place. The bad IP address is allowed three retries, and then it gets banned, and it's IP tables equals all ports is what it bans. So that address can't access anything on your firewall device for 15 minutes. Now we're going to talk about disabling unnecessary services and ports. I like netstat -pan, and you have to put sudo in front of that. The options stand for -p for programs, -a for all, -n for numeric, and -t for the TCP socket. As you can see from the screenshot, this command tells you about the device's programs with open ports. And the open ports are AFPD, which is part of Netatalk, SSHD, and Netatalk. And it also shows me being logged in through SSH. So sudo service --status all shows the status of all the services that are available on the Raspberry Pi. And the pluses indicate running services. The minuses indicate services that are not running. And the question marks indicate services that do not allow status as a possible command. So they are mostly commands that only run occasionally. So then I ran nmap against the Raspberry Pi, and it showed only 2 open ports, AFP, which again is part of Netatalk, and it had 22 for SSH. And then it showed, this is where it shows the client password, the clear text password right there. So I didn't realize that nmap would do that, but I was very grateful to find it. Backups. Backups are always a really good time. And you have several options available, as with anything with the Raspberry Pi. You can do a USB external or a flash drive. And what you have to do is mount the USB drive and then write a script to gzip the home directory and then copy it to a flash drive. And you can also encrypt the backups using tar and GPG. But then you have to make sure that the backups are complete for your purpose, and you also have to make sure that they're usable. So if you're going to back up the entire USB, the entire SD card, you need to get a fresh SD card and make sure that when you decrypt it, that it actually works. Because if your backups don't work, you're worse off than you were before because you did all that work and now you can't use them. So another possibility is using cron and just writing a script and to make sure that they run regularly. And again, you need to monitor them to make sure that the script is working correctly and both writing to the place that it's supposed to write to, and because if it writes to some place that, like a temp directory, and it gets deleted every time you reboot, again, you're hosed. So, and then you can also use a cloud account. I would prefer, if I was going to go that route, I would prefer a private cloud account that only I had access to, but I mean, it depends on your purpose. So this shows the Raspberry Pi interface actually working, and it shows the sensor, it shows the temperature sensor reading and the humidity reading, and then the camera. So I was very relieved when I got to this point. And this shows the monitoring website from my phone. And actually, this is through Chrome. It's not through Juice SSH. So the lessons I learned from this project was it was a good first approximation, but it's by no means functional. JavaScript is very slow and very error prone. I had a horrible time getting it to work. I installed it about, I swear, about 500 times. It was very difficult. And a lot of the modules didn't want to install correctly. And it obviously also needs a better case. Having the camera just flopping out here in the wind is a little disconcerting. And I haven't been able to find a case that the camera would fit into. So I'm assuming that I'm going to have to find somebody to print a case for me. I would particularly like to find a better, a simpler way to display the sensor readings in photos. One problem with the JavaScript is that it will only display the current temperature and photo. It doesn't keep anything the way he has the script written, which I think is, I mean, what good is just the current one? If you have a problem and you need to go back to your files to see what happened and you don't have any data, that's not going to do you any good. So that was another thing that I would like to change. And like I said, I would particularly like to find something besides JavaScript. So where do I plan to go from here? Well, you're only, as I said previously, you're only limited by your imagination. You can add more sensors and cameras and create zones. And the way I would approach that is I would put a Raspberry Pi in each zone, I think, and then have like a master monitoring system. And the next thing that I want to add is putting email on my Raspberry Pi so that I can send reports. And I would really like to add solar power. But the thing that really caught my interest was that you can build an Alexa device which uses speech recognition using a Raspberry Pi. Amazon has directions for that, and in the end under the additional references. But I think that would be a great challenge, and I think that would be really interesting to do. And the other thing that I would like to do is facial recognition. And I haven't read up much on what it would take to do that, but I saw some references to the Kinect. So you buy an old Kinect, and you can do a lot of things with that. And then automating system restart and shutdown. So with that, are there any questions?